Hello and welcome to week 2, Picturing the Universe. Now, a lot of modern astronomy is based around making images of the sky. Let's look at a few examples. Here is a picture of M31, or the Andromeda Nebula. It's completely outside our own Milky Way. It's the nearest giant galaxy to our own. Now, this picture is made up from a zoomable map of the Milky Way. The Milky Way is our own galaxy, the giant disk of stars that we live inside. The whole database contains about 1 billion stars. There's about 1% of all the stars in the Milky Way. It's made up of many, many infrared images stitched together and has taken many years to put together. Towards the center of the Milky Way, the stars start to blur together. It's hard to separate one star from another. This next image is the famous Hubble Ultra Deep Field. It contains thousands of extremely faint galaxies. They're very much like the Andromeda Nebula or our own Milky Way, but at huge distances. The Hubble Space Telescope, to take this picture, stared at a tiny patch of sky for several days on end to try and catch the light from the faintest galaxies possible. So to make a picture of the universe, the first step is to catch the light and focus it. To do that, the workhorse of astronomy is, of course, the telescope. I'm standing here next to a telescope at the Royal Observatory in Edinburgh. This is a 36-inch telescope, i.e. the mirror is 36 inches across, roughly 1 meter. It's a pretty old telescope. This was built in 1928, but the way it works is very much the same as any other telescope. However, modern telescopes do differ in 3 important ways. Firstly, they can be much bigger. Here is a picture of the Anglo-Australian telescope in Australia. It has a mirror diameter of 3.9 meters. Being inside the dome of the AAT feels like being inside a cathedral. It's enormous. Secondly, modern telescopes are usually on top of mountains. Here's a picture of the William Herschel telescope, which is on the island of La Palma at a height of 2,400 meters. Notice that we're looking down on the clouds. That tells you why it's so good to be on top of a mountain. And finally, modern telescopes can be in space. The most famous example is, of course, the Hubble Space Telescope. Now, in order to get science out of our images, several things are important. We want to get numbers from our images. Pretty pictures are all very nice, but we're trying to do science here, so we want to be quantitative. Next, we want to catch as much light as we can in order to measure the faintest things. The next thing is that we'd like our pictures to be as sharp as possible so we can separate one object from another. Next, we want, if possible, to take wide-angle pictures so that we can map out large areas of sky as quickly as possible, find rare objects. And last but not least, we want to take pictures at several different wavelengths. This is the key to getting physical information out of images. Here's the plan. In the next video, we're going to look at a specific science story, understanding the past life and predicting the future life of our own sun by comparing it to other stars. Then we'll look at how the technology works. Following that, we'll put the science and the technology together.